Now, what is abstraction? When client programs use the classes that you have defined, as shown in this example, they do not necessarily have to know how power was implemented. Okay, so we have here created an object for the television, and this TV will be used to access the public members of television. All the client has to know is what methods are available and how they are invoked, and what they do, and not worry about how. So this is essentially hiding implementation details from the user. And for example, these client programs. This is some form of abstraction. So this is a key OOP language component. The form of abstraction that you have seen so far is implementation level. What we are going to discuss in this section is a higher form of abstraction, that is the design level abstraction. In the real world, abstraction is focuses on ideas. What do we mean by this? Take appliance for instance. When you come across a word appliance, there isn't really a specific object that comes to mind. So, as opposed to, say, a television or an air conditioning unit, when you come across them, you know exactly what these objects are. And we say appliance is the abstraction of a television. And when the appliance is on, it does something for us, like condition a room to a desired temperature for the AC unit or show us some moving pictures of surface for entertainment using the television. So the appliance, which is this one, um, has to be manufactured. Maybe it has a model, as we have seen. Okay, then we just abstracted a design for an appliance from actual objects. So abstraction in Java is implemented via abstract classes and interfaces. So before implementing classes for a television object or an air conditioning unit object, this list can go on and on. There's too many appliance now, so it is best to implement an appliance class first. So okay, we will just create an a class for the appliance. Okay, we'll just reuse. Now, if we look at this class appliance, it looks like any class that we have seen so far. So far, we were able to model an appliance object. And notice that since we do not know what this appliance does, we simply printed appliance working. But only when the appliance is on. And if we will run this code, given the main method here, creating the instance of appliance, we have used up to invoke the public methods of appliance. We have here app the power to turn the appliance on. And now calling the work method. So when you try to run this code, we have here the output appliance working. So that's because we have turned on first the appliance using app.power and calling the work method, simply displaying appliance working. Now recall that we never meant for an appliance to be an actual object. The way appliance is in the sample code above is it is supposed to be an idea of an object and not an actual object. And if this is the case, there must be a way to prevent a creation of an appliance object. All we have to do to prevent this and to implement the appliance is an idea is to declare the class appliance as an abstract class. Okay, so that's the Java keyword for it. Now, to at this time, try to compile the code and there should be an error. So for the abstraction implementation, we're going to um, apply abstract methods. Okay, so abstract method is a method that has no body but only the heading, and of course is it must be declared with the keyword abstract, just like this one, public void abstract print. So print is the name of the method and it is declared using abstract. So this is the abstract keyword. So it's just only a method heading and with a semicolon, okay, or is ended here. Now, to implement abstraction in Java, we have to know the following concept. Abstract class is a class that is declared with the reserved word abstract in its heading. Then an abstract class can contain instance variables, constructors, finalizer, and non-abstract methods. And it can contain abstract methods. And if a class contains an abstract method, then the class must be declared abstract. And you cannot instantiate an object of an abstract class type. And you can only declare a reference variable of an abstract class type. Again, we cannot instantiate an object of an abstract class type, but we can declare a reference variable of an abstract class type. You can instantiate an object of a subclass of an abstract, okay, but only if the subclass gives the definition of all the abstract methods of the superclass. So let's try to implement an abstract method in this appliance class. Let us say this work method. Okay, we have to remove the method body. Okay, put an abstract keyword here. Okay, so there is an error, okay, with this statement. So when you hover this one, um, an identifier is expected. An invalid method declarations return statement is required. Now, there is an error for this one. So we need to, sorry, okay, misplacing of the keyword abstract. We have here public abstract void work. So we have made this work method an abstract method. So when you compile this one, let's try to save, then run, there is an error. One or more projects were compiled with errors. Now, there is error parsing the file. And there is a red flag under this class name. Appliance is not abstract and does not override abstract method work in appliance. So there is no other class. There is no other class that is overriding this abstract method. So therefore, okay, we need to declare this class abstract also. Okay, save. Then here in the main method, there is another error. So an error of this one, so it says appliance is abstract and cannot be instantiated. So as what we have learned earlier, that we cannot instantiate an object of an abstract class type. Therefore, in this main method, we cannot instantiate an object of an abstract class, but we can create a reference variable. Okay, and app is not allowed here to access the public members of appliance. Okay, again, we cannot create or we cannot instantiate an object of an abstract class type, but only the subclass of this appliance class can be instantiated. So on to um, we have to edit this appliance class and define it as abstract, but leave work and toString as abstract methods. So we need to modify. Okay, there is no toString here, so we need to put the toString method here. Public abstract string toString. Okay, so we have already two abstract methods, the work and the toString methods. And onto implementing the class television as an appliance, we are going to keep a very simple television object and have the following attributes. Now, let's try to create the television object or the television class first. Now, onto implementing the class television as an appliance, we are going to keep a very simple television object and have the following attributes. So we have the size, type, channel, volume. And we have an error for this, and when we hover this one, television is not abstract and does not override abstract method toString. So this subclass of appliance need to completely define the abstract methods of the superclass. So in the superclass, we have the following methods that are abstract: work and the toString method. Therefore, we need to put here the method definition of work and the toString method. Um, String toString. And there you go. Okay, so the red flag was removed under the television class since we have already defined the abstract methods of the superclass. Now, with the updated class television code, compile and see the errors. So there you have it, design level abstraction. So okay, there you have it. We have already the design level abstraction, and we have created the instance object of television, okay, to access the methods, power, and work. Okay, now, okay, so we have called the power and work methods in television, in which these methods are being overridden from the superclass methods, in which in the superclass these methods are being declared abstract. All right.